Now we will demonstrate the data collection capabilities of the MWL120 X-ray Laue detector system. We are looking at a sample of calcium tungstate this time. First, let's examine the real-time image. As you can see, there are many spots visible in the real-time image. Now let's take a look at the 5-second data collection. As you can see, collecting data over time gives a much higher precision measurement than the real-time image. You can see many spots clearly illuminated. We can also take this image and look at it with different cutoff levels, which, as you can see, reduce the background. If you cut off too high, some of the points become faint as well. We will use a value in the middle. Now that we have a collected histogram, we can auto-detect points. And now, if we want to index this image, we first need to select an indexing file or create one. In this case, we can select an existing indexing file, which has the basic information about the crystal structure of calcium tungstate. Now we can try to see if we can index this image. As you can see, we have found a solution. In fact, we have found 8 different solutions. Now let's go to the stereographic projection to try to visualize these solutions a little bit better. Now, we are looking at the first solution found. Let's cycle through some of these other solutions. As you can see, for the most part, these solutions are repeats of each other with slightly different indexing. For example, the first two merely invert some of these indices, but they're equivalent solutions. All of them, you will notice, point to this reflection being the 110 or equivalent axis. Now, this is very important because on a tetragonal crystal like calcium tungstate, we cannot simply rely on the symmetry of the image like we could before on the cubic crystal. Both the 110 and the 100 have a twofold symmetry. So unless you index the crystal, you can't generally tell the difference between the 110 and the 100. But with the indexing, we can tell that unambiguously. Now, from this calculation, we can determine how far away both this 110 is from our center. And you can see we're not off very far, which isn't surprising. But we can also figure out how far do we need to go to get to the 100. In that case, this is telling us that we need to go about 40 degrees to the side. So let's go back to real time and try to move there. And now we've moved about the right distance that our indexing told us. So let's take another image here. Again, we can auto-detect points. and index them. And indeed, this is the 100 that we're looking down. Now, in some cases, the auto-detect will not detect every point that you might be interested in. We can add points, and we can even subtract points if we don't want to fit them. Again, the stereoscopic projection is useful for visualizing where we are, and also for determining how far away we are. And you can see actually from lining up with the real time that we got very close to where we want to be. If we wanted to go to some other reflection, like say the 001, this tells us how far we would need to rotate it. Now we can also save these histograms. And open them up later. So you can save histograms for later analysis or comparison. This has demonstrated the basic capabilities of the data collection routines in our Northstar 7 software, along with the MWL120 detector system.